Here, one quick biochemistry basics here. Let's talk about gas chromatography. Gas chromatography is a chromatography technique used for the separation of volatile compounds. Volatile compounds are the compounds that get easily vaporized at room temperature. Let's see the components of gas chromatography. The column used in gas chromatography is very long and arranged in a coil. The columns used in gas chromatography are of two types. 1. Packed column. 2. Capillary column. Packed columns can be made up of glass or stainless steel. The length of this column can vary from 1 to 3 meters and has an internal diameter of 2 to 4 millimeters. The capillary column is made up of fused quartz. These columns are very long, with lengths from 10 to 100 meters and an internal diameter of 0.1 to 1 millimeter. The column is placed in a chamber so that a uniform temperature can be maintained. The stationary phase. The stationary phase is packed in the inner wall of the column. The stationary phase is made up of silicone grease or wax, which can withstand high temperatures. The mobile phase. The mobile phase used is usually an inert gas like helium or an unreactive gas such as nitrogen. The mobile phase gas is kept in a cylinder, which is connected with the column via a molecular sieve. The molecular sieve separates the unwanted hydrocarbons, oxygen, and water vapor that may interfere with the test sample during analysis. At the end of the column, there is a detector that detects the sample. Let's see the working of gas chromatography. The sample to be separated is mixed with an appropriate volatile solvent such as heptane, acetone, or methanol. Just before the column, there is a septum that allows injection of the sample. The temperature of the injection region is kept 20 to 50 degrees Celsius higher than the column temperature. This allows rapid volatilization of the sample. Once the sample is volatilized, it passes down the column where separation occurs. During analysis, the temperature of the column is kept between 150 to 300 degrees Celsius. Separation occurs based on the interaction of molecules between the mobile phase and the stationary phase. The less volatile molecules interact more with the stationary phase and move slowly, while the more volatile molecules interact more with the mobile phase and move faster down the column. Once the separation is completed, detection is done with a detector attached at the end of the column. One of the most common detectors used with gas chromatography is the flame ionization detector, or FID. The flame ionization detector has 3 inlets. One for the carrier gas, which comes from the column, and the other 2 for hydrogen and oxygen. The igniter ignites hydrogen and oxygen to produce a flame. When the sample molecules reach the flame, they get ionized and electrons are released. Across the flame, there are 2 electrodes, each with a positive and a negative charge. The electrodes detect electrons generated by the ionization of the sample. The electrons are detected in the form of current, which is amplified and detected by the computer. When the sample is detected, the computer gives a peak with respect to the retention time of the sample. The area under the peak provides information about the concentration of the sample. If the concentration is low, the area under the peak will be small. If the concentration is high, the area under the peak will be larger. Now, for the detection of unknown samples, we need to have standards. Let's understand this with an example. Suppose we run methanol as our sample, and the peak of methanol is obtained at 5 minutes. Next, we run acetone as our sample, and the peak of acetone is obtained at 3 minutes. Next, we run an unknown sample, and we get this chromatogram. Now, using information from the standards, we can say methanol is present in the unknown sample, whereas acetone is absent. The remaining peak is still unknown as we do not have any standards to compare its retention time.